Hello guys, welcome back to my channel DP Design, and in this video I am going to teach you how to do the simulation of compression spring using Abacus. Okay, so firstly into the model we have to create two fixtures which is connected to both hands, and the fixture will move to compress the spring. Okay, so for that we'll start the modeling of the first fixture. Okay, so the fixture will be the square. Okay, like that, and you can dimension it like 100 by 100 will create, no issues. 100 by 100. Okay, and whatever this thickness you can give, like you can give 5 mm, and it should be not merged. Okay, if you merge it, then the whole part will become one part. Okay, so it will not separate the fixtures and spring in Abacus. Okay, I'll teach you that how to do that. First off, you do the merge result off, untick that, and yeah, for first fixture is ready. Second fixture will create over here. The same we will assign. Okay, convert entities. Okay, is has been created as per bottom fixture, and also we have to extrude 5 mm. Okay, no merge result. Okay, so this is, I think, 15 mm is there, so we have to change it to 5 mm and click it OK. Okay, now refresh it. Okay, now done. Now you convert this file into step. I'll just go to the save as, and desktop, trash, and I'll create one folder which is a spring. Okay, spring. Now spring, it is a step file, step, squared end, save. Now I have to import the model in here. So firstly I will do graphic setting, which is the default. Okay, apply. Okay, now go to the part. First we have to import the part here. Import the part. Go to the I have to locate that actually, desktop, and then you go to this trash, go to this spring, and yeah, the spring file is there. So you have to create spring file, which is step file. Okay, now there is an option which is the create individual or single part. So I will create the individual part, because in single part there is a only fixture also will be merged with the spring. Okay, so this is not, that it will not good, because if you want to apply the rigid part, then how you can give the rigid part to the fixtures. Okay, so you have to apply individually. Okay, so create individual parts. Okay, I'll just go to very fast, because I have explained all the steps in the previous videos. I am just explaining you one example how to do the perfect simulations. Okay, so for spring I have created the material over here. Material was in the library only, so I will apply the material. Fixture you can give the steel as well, because this will be going to be rigid only. So it is not, even if you give any material, so it will be rigid only. So material properties will not affect the fixtures. Okay, so it will affect the spring only. So spring has been applied. Step I will create the general, and increments I will give the 0.1, and minimum increment I will give 50. Okay, now coming to the field output. In the field output you can select whatever, select from the list of stress, strength. I don't want the contact I want. Okay, contact I want, forces, displacement, velocity, acceleration. So in that u is there. Okay, I want all the parameters. Okay, so step has been created. Now what you can do, you can just go to the assembly, select the parts. Okay, now as you can see, select the parts, and constraint, before going under constraint we have to select the RP1, which is connected to this portion. Now I will tell you how to make the rigid parts. Okay, so focus on that. Go to the constraint, then rigid body, then select the body which you want to constrain as a rigid, select rp1, rp2. Okay, now this part is connected with the rp2 and is rigid now. So the same we have to apply for the rp1. Continue, body, okay, select the point, okay. Now I am done. So this is the done, the process has been done. Now what you can do, you can just go to the interactions, go to the general contact, create one contact between steel to steel which is a 0.27. okay, from experimental we have taken this value, so 0.27 is coming. So 0.27 is the frictional coefficient between the interactions. So now I am done with that. Just wait a minute. Okay, applied. Okay, now the interaction has been done. Now what you can do, you can go to the mesh part, go to the part, and you can select the minimal meshing value and select the tat mesh for the spring and create the meshing. Okay, just wait for the meshing to be completed. Okay, now meshing has been completed. As you can see, for the fine meshing you can apply the laser element size, or you can do the hyper mesh. Okay, so for three different parts, as it is a independent mesh, so for three different parts we have to apply. So for that, even if you apply the smaller element size here, there will be no effect because it is a rigid part. Okay, so you can create as it is. Now go to the assembly. My totally part has been meshed. Now I have to apply the displacement or force, whatever you want to apply, whatever data you have. So in the displacement, I will apply the displacement 2 mm of displacement. I want to see the load only for per mm how it is coming. So in the initial, I will just fix this bottom point which is connected to this part. Okay, so the rigid part will be constraint. So this is the constraint. Now I will apply the displacement in this direction. Select the part, and no, I just want to create this displacement into, just a minute, the step I have not created, step I have created step 1. Okay, so what I have to do, I have to go to step 1 and then displacement, and then yeah, then connect u1, u2, u3, ur1 all 0, but in this y direction, y minus direction. So I have to apply the 4 mm. Okay, I will apply the 4 mm of travel. Let's see. So 4 mm of travel, it will come downside. And now I am done with the pre-processing. Now I will apply the results, where my result is going to saved. Okay, results, which is a job 1. Okay, I will submit the results now. Okay, monitor, now it is running. Okay, so after running, in next video we will see the post processing of it, how to get out the force values. Okay, how much is coming, so that we will see in the next video. So this is how you can pre-process the spring, compression spring. So this is how you can do the simulation of the springs. Okay, so that's it for the video. Thank you for watching. If you really like it, keep sharing, keep supporting, and thank you so much.